Hi Applied Maths students, welcome to our channel Maths Plus U. We are doing class 12 Applied Maths Unit 3B Integration and its Applications children student support material. We have already done the two parts. This is the third video. In the exercise 3.1 what method we are going to discuss means substitution method. First we will do some example basic model, then we will do the handbook sums, CBSE book sums we will do it after. First integration by substitution method. Why we wanted to do substitution method? First, for that question we want to answer. Reason is we have a two functions when they're in numerator and denominator. Numerator denominator you can use quotient rule u by v the whole dash. Quotient rule we can use in differentiation. Correct, children? This is integration. So we can't use the quotient rule. Then we are doing a substitution method. What's a substitution method means? You have to take one term as t. Not only t, any another one variable apart from x, anything you can take. You may take 1 plus x square or you may take 2x. Okay. So once you taken one term as t as 1 plus x square, you have to differentiate. When you differentiating, I am saying correctly. Okay, even here integration is here. For substitution method, we want to do differentiation. So t I am going to differentiate with respect to x na dt by dx, and I have to get one differentiation 0 and x square differentiation 2x. Somewhat related. If I taken t as 1 plus x square and I am getting 2x, so that way I am taking 1 plus x square as t. Someone understood? So 1 plus x square as t. So I am differentiated and I got 0 plus 2x. Actually t differentiation dt by dx, division dx goes it's in a multiplication. So 2x dx is dt. Why you are taking 1 plus x square t? I will take t as 2x. For you okay va? Like that you asked. Huh? If you taken 2x as t, then if you differentiated 2 into 1 2 and equals dt by dx, so you will get 2 dx equal to dt. Actually 2 dx equal to dt you got now. Then you can't get the 1 plus x square to remove. So in that sense, so it is not you, we have to decide it. From the question, you have to understand and should decide which you taken t, that you differentiated again, the balanced term. Exactly balanced term comes also okay, or at least related to the balanced terms comes also. When you're doing more substitution method, you will understand better. Okay. So why I have taken 1 plus x square as t, somebody understood? Okay. After 1 plus x square t, just want to substitute, children. How to substitute now? I equals 2x by 1 plus x square, no? So in that way 2x dx is there. So instead of the 2x dx, I am applying t dt. Then 1 plus x square I taken t. So I equals integral dt by t. How we got understood? I repeat. So 2x dx is dt and 1 plus x square as t. I have changed the variable x to t. Now I have to differentiate what with respect to t only, because dt is here, 1 by t dt. We all know, children, 1 by x dx integration is log mod x plus c. Correct or no? We have the formula standard integration. You can just check the formula. It is there in this formula available in the first video. So log mod t plus c. The t value is 1 plus x square. So log mod 1 plus x square plus c. Is this easy, children? So we have taken one as t, one term as t, numerator, denominator, which differentiated, another one should come. Okay. So I think I have taken the denominator as t. Okay, now go for Alator method. What's our Alator method now? So kindly see, here if I am considering the denominator as f of x, 1 plus x square. If I differentiated, I got 2x, that is there in numerator. So like this comes now, I can use this formula. This also I have given in the first video, kindly check. In the formula thing, integration video number 1. Integral f dash of x by f of x dx log mod f of x plus c. Clear? So what's our advantage in it now? I don't want to substitute all these things and all. Just wanted to apply the value. So I got f of x as 1 plus x square that differentiation that differentiation is f dash of x. So integral f dash of x by f of x dx log mod f of x plus. So got the answer. I equals log mod 1 plus x square plus c. Clear section. So this can be substitute like this comes now only directly integral f dash of x by f of x comes now. Okay, second question. Again in examples, log x the whole square by x dx. So here what's last time denominator only t, always denominator t, okay like that na? No, not like that. As I said already, suppose if you're considering denominator only always t na, x if you're considering t, x differentiation 1, so 1 equal to dt by dx, so dx equal to dt, that won't help you to remove the log x. Clear around. So I can take log x x t. So if you consider log x as t, log x differentiation 1 by x, t differentiation dt by dx, directly also the dx you can keep this side. So 1 by x dx equals dt. So now we substitute children integral log x whole square is there. So log x value is t. So integral t square. Is this correct? Check integral t square. Then 1 by x dx. Here this is like 1 by x dx by x. Okay, so the 1 by x dx is nothing but dt. So that place we can write integral t square dt. Once integral t square dt comes, clear check how integral t square dt comes. So we just substituted the value. Instead of log x t, t square 1 by x dx is dt. So t square integration we all know, hopefully, integral x power n dx. What is integral x power n dx, children? X power n plus 1 by n plus 1 plus c. Correct or not? So substitute t power 2 plus 1 by 2 plus 1 plus c. So if you are doing this, t 2 plus 1 is 3, t power 3 by 3 plus c. Always remember my substitution method. But t over like that don't keep. You should substitute the value of t at last, because for our convenience we are changing. We should substitute the value. So t is log x. So log x the whole cube by 3 plus c. So now examples we have discussed, children. So we are doing the sums in the exercise 3.1. Evaluate the following by substitution method. So very clearly they itself said it's substitution method like that. Integral x plus e power 2x by x square plus e power 2x. So denominator you take x square plus e power 2x. I'm considering it as a t. So we supposed to differentiate. So I'm taken this to get that. Actually, this x I taken x differentiation I won't get x square, but x square differentiation I will get 2x. So related to it. So only I have taken denominator as t. Why denominator t? Somewhat clear. Check. So x square differentiation 2x. And e power 2x differentiation is e power 2x into 2. So as I say, denominator I am doing and I am going to get somewhat related to numerator. So I just try to take common 2 as common. So we got it as x plus e power 2x. So but we need only x plus e power 2x in the numerator. If you want, you can check. So the 2 we don't want. So we can just keep that multiplication to goes with a division and as dt by 2. Once we got dt by 2, I have written I and what? This numerator x plus e power 2x dx is nothing but dt by 2. And this 1 by x square plus e power 2x is t. So 1 by t dt by 2 clear. Then that 1 by 2 take it out, children. So we got like this and 1 by t dt. 1 by t integration is nothing but log mod t plus c. Then substitute the t value. X square plus e power 2x plus c. Is this clear? Then go for the second one. So that is nothing but integral dx by root over x plus x. So this x we are splitting into root x, children. Correct? This x like 2 we can write it as 2 as root 2 into root 2. Same way can we split x as root x into root x. Is this okay? That's what we have done. Then take something common, root x common. Then I'll get 1 plus another root x. So 1 plus root x taken as t. Clear? Check. then differentiate. Actually, I have striked one thing. What I have striked now, in my mind I was very clear, 1 plus root x differentiation, 1 differentiation 0, but root x differentiation 1 by 2 root x, the 2 root x should be in denominator, but firstly when I am written 1 by 2 root x, I have written it up, so that is not correct. So always remember 1 by 2 root x differentiation. So substitution method we are doing here, this place differentiation, so that is nothing but dt by dx. Then 1 by 2 root x division dx goes inside now multiplication. So we got 1 by 2 root x dx. We have only 1 by root x in the question. If you want, you can see. So 1 by root x dx alone is there, like a last sum. The 2 we are keeping in the numerator, then become it as 2 dt. So 1 by root x dx is nothing but 2 dt. So can we substitute, children? If we substituted, we were getting it as 1 by t into 2 dt. As usual, to take common 1 by t, again same thing, 1 by t integration we all know, log mod t, log mod t. We should substitute the t value as 1 plus root x. So I equals 2 log mod 1 plus root x plus c. Clear a check. Actually, with the first part only you have to understand which you have to take t and how to proceed. After that, very easy. Same way here, which you going to take t. Like that we have a question. Denominator have a whole square and the denominator have what, 1 plus x e power x, and here only 1 plus x. So we are taking as what, denominator 1 plus x e power x, not whole square, only 1 plus x e power x we are taking t. But till now we are not have any product rule in the t when we are taken, directly we have differentiated. But here we wanted to take x e power x differentiation, means you have to use product rule. U is x, v is e power x, u dash is 1, v dash is e power x. We all know uv the whole dash equals u dash v plus v dash e. So hopefully you have completed unit 3a, that we have completed children differentiation and its application, 30 videos, that if you completed, definitely these concepts you know. So kindly, if you have a doubt, go through the unit 3a differentiation and its application. That video, that link also available in our comment as well as description. Okay, so now do as it is. U dash v, u dash is 1. Actually the 1 differentiation is 0, then u dash is 1, v is e power x, then plus v dash again e power x, u x equals dt by dx. The division dx comes here, here. Then e power x plus x e power x we have written. So anything you can take common, I check. We can take e power x as common. E power x you are taking common, you will get it as 1 plus x. So e power x times 1 plus x dx equals dt. Clear, check. Once you have done this, then just want to substitute. E power x 1 plus x dx is dt by 1 plus x e power x as t square. So we got, as usual, integral dt by t square. But one change what na, last time we got only 1 by t. So 1 by t integration log t like that. But here we got t square. It's like 1 by a power m. It's nothing but a power minus m. Is this correct, children? So may I write it as t power minus 2. So integral t power minus 2 dt, correct, check. Because of 1 by a power m, a power minus m. Now integral x power n dx formula. X power n plus 1 by n plus 1 plus c. So t power minus 2 plus 1 by minus 2 plus 1. So minus 2 and plus 1 you add and I getting minus 1. Again denominator minus 2 plus 1 minus 1. So again a power minus m, we all know what is a power minus m. A power minus m is 1 by a power m. So we got it as minus outside, the t power minus 1 we got it as 1 by t. So I substitute the t value, children. So only it's substitution method. So t we substituted, we are getting 1 plus x e power x plus c. So today the last sum, integral 2x by cube root of x square plus 1 dx. So I we have taken as cube root of x square plus 1. So x square plus 1, take it as t. X square differentiation 2x, t differentiation dt by dx, 1 differentiation 0. Division dx goes as a multiplication. So we are getting it as 2x dx equals dt. So substitute integral 2x dx is nothing but, what is 2x dx? that is nothing but dt by cube root of t. Understood? Check children. Cube root of x square plus 1. So integral dt by cube root of t. So cube root of t is nothing but t power 1 by 3 children. Correct? Check. So once it is t power 1 by 3. Again 1 by a power m is a power minus m. So t power 1 by 3 we can write it as t raised to the power minus 1 by 3. We all know integral x power n dx is x power n plus 1 by n plus 1 plus c. So t power minus 1 by 3 we are integrating. Now we are getting it as what we will get? T power minus 1 by 3 plus 1 by minus 1 by 3 plus 1. So if we are taking LCM, 3 minus 1 we are getting 2. T power 2 by 3 by 2 by 3 plus 1. Then we have the division 2 by 3 comes the same, 3 by 2. So I equals 3 by 2 t power 2 by 3 plus c. T value is kindly substitute children, that is nothing but x square plus 1. So I equals 3 by 2 x square plus 1 whole power 2 by 3 plus c. Clear? Check ma? Kindly forward to applied maths students, it will be useful for them. Thank you.